In this video, we are going to go over amides, the functional group amides. So an amide is a carbonyl group in which the carbon atom is bonded to an NH2, an NHR, or NR2 group, and the usual R group. The condensed notation is either RCONH2, RCONHR, or RCONR2. Proteins are a large class of biomolecules that are characterized by the hundreds or even thousands of amide functional groups that they contain. Amides and proteins are formed from amino acids, so proteins are made up of amino acids, and the amides and proteins are formed from the amino acids. So these are the three different structures that amides can take. We have the carbonyl carbon bonded to an R group. This is the same in all of them. And the only difference is the nitrogen, how many hydrogens in R groups it's bonded to. So here are examples of some amides, or amides, however you want to hear it or say it. We have methenamide or formamide. It has carbon double bonded to an oxygen bonded to one hydrogen, and it's bonded to nitrogen bonded to two hydrogens. We have ethanamide, which is a CH3 group bonded to the carbonyl carbon. The carbonyl carbon is also bonded to an NH2 group. N-ethyl propanamide is a carbonyl carbon bonded to an ethyl group, and a nitrogen bonded to a hydrogen bonded to an ethyl group. And then we have N-diethyl or dimethyl ethanamide, where we have a carbonyl carbon bonded to a methyl group, bonded to a nitrogen that's bonded to two methyl groups. So this one has two R groups bonded to the nitrogen. So amide versus an amine, the carbonyl plus the bond to nitrogen and a single bond to an R group is what makes an amide. A carbonyl directly bonded to the nitrogen acts as a unit. The carbon-nitrogen bond within an amide has some double bond character to it, and it does not act as a base. Amines act as base, and amide does not. So the difference between an amide, here's an amide, we have the carbonyl carbon and the nitrogen. An amine, we just have nitrogen singly bonded to either hydrogens or an aromatic or an alkyl group, not a carbonyl carbon. So to practice, we're going to write the skeletal line structure for the condensed structures shown, and then are there any compounds that are not amines? Remember, for skeletal line structures, anything that's not a carbon or a hydrogen, you need to write out the letter. So we have CH3, CH2, so CH3, CH2, a carbon double bonded to an oxygen, double bonded to, or bonded to a nitrogen, this nitrogen is bonded to a hydrogen and a CH3 group. This has the carbonyl carbon bonded to a nitrogen. This is an amide. We have a CH3, CH2, NH2. There is no carbonyl carbon in this structure, so this is not an amide, it's an amine. In the following structure, we have 1, 2, 3, 4 carbons. So 1, 2, 3, 4. 1, 2, 3, 4. Then we have a carbonyl carbon bonded to a nitrogen, bonded to two hydrogens. So 1, 2, 3, 4. Carbonyl carbon, nitrogen, bonded to two hydrogens. This is an amide because it has this carbonyl carbon bonded to a nitrogen and an R group and two either hydrogens or R groups bonded to the nitrogen. So peptides are amides or amides in nature and pharmaceuticals. Peptides are compounds derived from amino acids, which contain one or more amide groups. Endorphins are peptides that bind to opioid receptors, functioning as the body's natural pain relievers. You can see met and kefalin is derived from 5 amino acids joined together by 4 amide functional groups. So you can see here that we have 1, 2, 3, 4 amide functional groups. And this is how the different different amino acids bond together. Amides in nature and pharmaceuticals, another example is penicillin. So penicillin antibiotics have 2 amide functional groups which react with a key enzyme in bacteria that's required for building the bacterial cell wall. So when penicillin antibiotics react with that enzyme, then they can't build that cell wall and it kills the bacteria. Since our cells do not have cell walls, penicillin doesn't interfere with any important enzymes required by our cells. You can see that amoxicillin is an example of a penicillin antibiotic. It has an amine group, but it also has 2 amines. So the structure of ethanol, a drug used to treat angina, is shown. So highlight and label the amide, amine, ether, and secondary alcohol functional groups. So go ahead and pause the video, and when you're ready, come back. Do it together. So we have an NH group. It's not bonded to any carbonyl carbons. So this is an amine. OH is an alcohol, and it's a secondary alcohol. We have an oxygen singly bonded to R groups. This is an ether. This is aromatic. We have nitrogen bonded to a carbonyl carbon. This is an amide. So in summary, amides are characterized by a carbonyl group with a bond to an R group and either NH2, NHR, or NR2. The condensed notation for an amide is RCONH2, RCONHR, or RCONR2. It all depends on how many hydrogens or R groups the nitrogen is bonded to. Proteins are biomolecules that are characterized by their numerous amide functional groups or amide functional groups, which are formed from amino acids. The carbon-nitrogen bond within the amide group has some double bond character to it. They do not act as bases like amines do. And peptides are compounds derived from amino acids which contain one or more amide groups.